joined Michael Hopkins and Partners in 1978 and has been a partner at the practice since 1981. Over the years since 1978, John has worked on a number of significant projects, including the Green King breweries, Schlumberger Labs, the Mount Stand at Lord's, Bracken House, the two buildings for David Mellor, and most recently the parliamentary buildings. In a number of these projects, he's also worked in collaboration with Bill Dunster, who is a unit master in intermediate school, in Intermediate Unit 7, and was one of the organizers of the symposium on sustainability, to which John made a contribution on some of his more recent work on low energy research. As I said, John has been very much supporting the AA. He joined the AA Council in 1987 and became the president of the Architectural Association in 1993. He was the president between 1993 and 1995. It's a great pleasure to have him give a lecture here in conjunction with the exhibition on the David Mellor building upstairs. Would you please join me in welcoming John Pringle?
I must say this makes a change from the school community meetings, which is the last time that I stood up here. Perhaps if I put the slides on. I'm going to talk about this building on the right. The context of it is that we'd, in fact, just completed an earlier project for David Mellor, who's in fact here tonight in the audience. We'd first of all done the cutlery factory at Hathersage, which was the round building on the left. And then this project was for a new building in Docklands, which was going to be an apartment and a showroom and an office building. And in many ways, in terms of our office's output, it's a bit like a sort of snack compared to the enormous banquet that we're doing with the parliamentary building. And that's not to really belittle it. It's because sometimes I think the nicest meals that you have are snacks which have fresh ingredients and very simple ingredients that you put together and can be just as rewarding as a 5-course meal. And on this building, we couldn't search out all the exotic ingredients that we put into some of our other projects, and the client had a restricted budget and wanted the maximum space for the money. And so we really had to look into the cupboard and make use of what was already there. And what I'd like to do this evening is to trace the way that some of the ingredients that we put into the building had developed and how they came to be in the cupboard in the first place, and how we went on and used the ingredients that we developed here on other buildings, and show how they were used in other recipes, as it were. This was a building where the name of the game was doing the project quite quickly and very freshly. And it's quite interesting how on other buildings you can use the same materials and some of the same techniques, and they come out with a completely different and perhaps more subtle interpretation. Whereas here, what I liked was the directness of the building. The site of the building was in Docklands. It's Shad Thames, just near St Saviour's, facing onto St Saviour's Dock. And what we found was the buildings on the right-hand side, and in fact the site was this building and a bit of this. And we had a very protracted negotiations with the English Heritage to demolish the building on the right, because it was about the only old building in the area, but in fact it had been built for child labour and storing sacks, so there was only a headroom of about 1.7 metres, and it was impossible to use for any other use at all. And we had absurd conversations with the conservation officer, who was about nearly 2 metres tall, who said it's perfectly capable of reuse and was sort of hunched double inside this building. But eventually, after about a year, 9 months of negotiations, we managed to get permission to demolish it on the basis that the replacement building would be an improvement. The use of the building is really quite simple. There was an apartment on the top, 3 floors of offices, and what was to be a workshop on the bottom floor. Sorry, the slide on the right is wrong. No, it is the right way around. I thought it was the wrong way around. The plan really was developed around the apartment, and we developed quite a simple format where it was based around a number of individual rooms and on bedrooms on the street side, a double height space in the middle that led up to roof terraces, and then living rooms and on the other side of the building with bathroom spaces. And that really dictated the plan form, because that was the most onerous part of the building. It dictated the plan form for the rest of the floors, where the offices and the workshops had much less onerous uses. So we arrived at the plan and the format relatively quickly, and this shows the components of the building, and where we had the 3 floors of offices in the middle, the apartment at the top, and the showroom at the bottom with a basement car park. And then the construction concept was relatively simple. We had a concrete frame in the middle of the building, the main block, with a freestanding lift tower up the side, and then external cladding panels just clipped into the frame, and with a sort of leftover space for services and cores against the party wall. And really the challenge was how to make the best expression of these of this very simple plan using a relatively limited palette of materials. And in the end, we settled on 4 materials, which were steel and glass, lead and concrete. And you can see them all in this picture. There's the concrete, and then there's the steel for the lift shaft, and the lead panels, and the glass for the windows. And I think in many ways the materials, in taking the sort of culinary metaphor, the steel and glass were very familiar to us. All our upbringing as a practice had been on steel and glass. We knew it very well. It was second nature to us. It's like the sort of sauce that you put into every dish, or every standard dish. And then the lead, in a way, was something that was in season, because we'd just had an experience with David Mellor on the Hathersage building, where we had a lead roof, which was prefabricated in panels. And then the interesting one, and really what the essay that we developed on this building, was concrete, and how to get maximum expression out of concrete. And it was like the sort of forgotten ingredient at the back of the cupboard that needed to be reinterpreted into something more interesting than most associations one has on recent projects. And in many ways, the biggest inspiration for us as a starting point was this building by Louis Kahn, the Yale Art Center. And what appealed to us was that here was a building with a very limited palette, the multi-story concrete frame, that would solve very efficiently all the fire resistance problems, and that the concrete also has the potential to provide a fair face finish. And in this building, it was the panels on the side of the building were stainless steel, sort of matte stainless steel, mill-finished stainless steel, and then inside there's joinery. And that's what we set out to use. And we had a romantic notion that with David's work in manufacturing cutlery and the use of stainless steel, somehow we could redeploy that technology and use it on this building. And then likewise, we thought at first that we would reuse the timber from the demolished warehouse on the site for the panels inside the building. But in fact, neither of those 2 ideas survived. Interestingly, Louis Kahn himself likened the stainless steel panels on the Mellor Centre to lead or pewter. And we had this immediate experience on using lead, so that became the main material of the cladding. Just going through the materials, and quite a lot of what our work is that we really take an ingredient that's already there, that we've already developed out of the sort of back catalogue, and if you take the lift tower here, which is all metal plate solution, and this was something that we'd really first developed on Lord's Cricket Ground, where we hit on the idea for a very long span structure. You could have your structure, which would also form the enclosure to the building, and and you could do that very, very efficiently, and you get the aesthetics are developed from the pattern of web stiffeners that you need in the thin steel plate. You use a standard thickness of steel plate and weld web stiffeners on. And we did the same here. And in fact, on Lord's, at the end of the stand, there was a lift tower, where the lift tower was just delivered to site in 2 sections and stacked on top of each other. And we took the same thing on this building as a sort of ready-made solution. We can only really manage one new idea on every project, and we have to we start off with a lot of ideas that we've developed on previous projects, use them again relentlessly, and then try and develop something new. And this was one that we weren't going to develop on this project. And you can see at Lord's, this is a shot during construction where we had the plate girders, which spanned 18 metres along the length of the stand, and they formed an enclosure to the service rooms, which are below the top viewing deck, and below the plate girders was suspended the boxes and the dining rooms. And then inside the building, this is the Shad Thames building, all you needed was, you didn't need anything. You just had the plate steel, which was painted. We didn't need to insulate it because it wasn't a heated space. And we strongly believe in not solving problems that you don't need to solve. So why bother with insulating it and all the conventional paraphernalia of construction? This is really a sort of cross-channel ferry aesthetic where you just bolt things onto the hull of the ship. And I think a lot of the inspiration we had for this was from shipbuilding. And in this case, they was bolted together in story height sections. And you can see how we've used this idea again at the more or less the same time at Bracken House. This is the atrium in Bracken House where we had the lift shafts that supported the roof structure, and they were again plate steel. And then in the Shad Thames building, the lift shaft, and it sort of takes a lot of courage with this architecture where you have nothing else is going to happen to it, and the site looks like a pigsty while you're building it, and you see what are supposed to be finished components, and they don't look very impressive when you put them in place, and you just have to sort of believe that it's going to be all right at the end of the day. But here they were just delivered off the back of a lorry and put on top of the foundation and stacked on top of each other, and then the stairs and the lifts were all fitted out inside. So then the next detail and the next sort of technology that we took out of our back catalogue were the lead cladding details. And this is the Hathersage building we did for David. And this roof was made of plywood, stress skin plywood panels that were hooked onto purlins. And then there was a lead covering on them. And that in fact, they were all made by David Mellor himself. And in a way and he was very much involved in a lot of the fabrication of, well, both this earlier building and particularly this later building. And I think it was the confidence that we had, we got to know lead, and we rather liked the idea of a material, unlike a lot of the materials of modern movement in architecture, which get worse with age. Lead and non-ferrous metals actually improve with age. They develop a patina, and the appearance in many ways improves. So, but on this building, we were going to use it as cladding in a similar way to the Khan building, but with panels on the side of the building. And what intrigued us here was that I think David's background of working with metals, and I think he trained as a silversmith, he sort of tortured this metal into something with knife-edge creases, quite unlike normal lead on roofs. And you can see these sort of razor-sharp arises on the joints. And that, for us, that was a revelation. Because one so put off by lead conventionally on buildings, where you see the sort of rather this metal that's rather difficult to control, where and it looks as if it's got the better of the people who are working on it, you conventionally see on roofs. But here there was a fantastic precision to it, and that we found a complete revelation. And this shows some of the details where we had a ventilated void in the cladding, and David manufactured all these panels, and they were in the galvanized steel frames. But in the end, we had plasterboard in the inside instead of the wood panels that we'd hoped for at the beginning. And this is another. This is an internal view where you can see the framework that supported the panels. And then this was a detail that we used again relentlessly in other projects, having developed it on this one. There, on the left is the Glyndebourne Opera House, where we had similar lead panels cladding the fly tower. And in fact, the roof is really a straightforward development of what we'd done on the Hathersage building. And then again on the Inland Revenue, there are lead panels up on the top floor. This is in Nottingham. And there's a lead roof again. So this project proved to be an important development of that sort of part of our architectural vocabulary that we sort of developed on this project. And then the next thing that we took out of our back catalogue was was glazing, and what we were looking for were just big, simple sliding windows where the building would be naturally ventilated. We wanted the maximum area of glass because the two side walls of the building are relatively solid and the ends were glazed, so light had to penetrate a long way into the building. And what we used was the system that we'd first developed on the Schlumberger building, where we in fact tried to reinvent far too many things, but we managed to get away with most of them. But on this one, we had again, big over 3 metre high, effectively they're patio doors, and we thought, well, we'll just use patio doors, but in fact, you find they're never built for anything higher than about just over 2 metres. And so we had to develop a whole new glazing system with Schuko, a German manufacturer, where the 13 new extrusions, which were had to be robust enough to span the 3 metres and could support this large area of glass. And that was something that we developed on the Schlumberger project, and having sort of sorted that out on that project, it was a pity not to use it again. And we used it not only on David's building, but Bracken House in the atrium, in the middle atrium space. There was these balconies that faced out onto it with these same extrusions. And then at the Inland Revenue Centre in Nottingham, on the amenity building, we used the same extrusions again. So on David's building, it was just an interim step on the way of something that we had already worked out. And then again on the roof glazing, we had a ready-made bit of the vocabulary, which was really a patent glazing system that didn't need any secondary support, and we'd first used that on that Schlumberger building at Cambridge, and this gave a very structure-free double-height space in the apartment level of the building. But the real challenge on the project was concrete and how we could express the properties of concrete. And we'd become very disillusioned with the way that concrete's used in buildings. 90% of buildings you see put up have it concealed behind cavities, behind suspended ceilings, behind curtain walling. You never see the structure. And the whole concrete industry had become very de-skilled, and because no one, since the National Theatre virtually, had ever asked for fair-faced concrete. And no one was used to producing good concrete. But in the aesthetic of this building, where we were stripping everything back, peeling all the layers off the building, everything that was unnecessary, we were anxious to find a way of expressing what the nature of the material is. And our only previous project that we used concrete on was the Solid State Logic building in Oxford, which was a very simple first floor slab, and but it had coffers in it, which you can't see in this photograph, which we cast light fittings into. And we really, on this project, we wanted to take it a step further. Other projects that we'd used concrete on about the same time were Bracken House, where it was very sparingly used on columns and beams that you could see in the office areas. This is the new section of the building, which had a concrete frame behind a bronze facade. And this was another part of our continuing interest in non-ferrous metals, that actually develop a patina. Bronze actually becomes develops sort of weathered patina, which improves the time. And that was something that we'd sort of picked up from the existing building that we found, the Albert Richardson building. So there were a lot of similar themes in the same time, all in the melting pot. And in Bracken House, we had these clear office areas with these columns on a 3.6 metre grid. It was on a radial plan, and they formed cellular rooms around the outside, and the beams were expressed in a very fine precast concrete in the ceiling, and then the ceiling formed air ducts and lighting between the beams. And so we'd had a limited amount of experience with precast concrete. But in David's building, we were really after something that was would express the concrete as a more plastic material. And I think we felt, in fact, I recommend reading Nervi if you want to get enthusiastic about concrete. And he's incredibly poetic, and he wrote a book called, in English it's translated to Structures, but in Italian, the Italian original means building correctly. He sort of says with certainty, and it sort of goes from the sublime to the ridiculous. He talks about architectural education in general, and then tells you what density of reinforcement you need per cubic metre of concrete. But it's a wonderful book, and he's saying that reinforced concrete is the best structural material yet devised by mankind. Almost by magic, we've been able to create melted stones of any desired shape, structurally superior because of the tensile strength to natural stone. Enthusiasm is dampened by habit, but reinforced concrete deserves a large measure of it. And in a way, he sort of gave one the way of looking at concrete and how you use it, and what's the nature of the materials you're using. And we often forget that concrete needn't necessarily just be the ready mix that comes out of the truck. Although, ironically, on David's building, we did use ready mix, and we couldn't get a more refined expression out of the raw materials. But basically, concrete is stone that's quarried out and ground up, and then the other components are a lot of joinery, which has to be very finely made joinery, and reinforcement. And it's how to put those components together in a poetic way, so that somehow you could read through in the finished product the underlying beauty of all those components and the way that the structure is working. On other projects like Bracken House and the Parliamentary Building, we're actually selecting the components, and we learnt a lot from the Japanese who we were working with on Bracken House, where they talked about the wonderful river sands that they used as the constituents of the concrete instead of all the sea-dredged aggregates that we tend to have. And that sort of opened up our eyes that actually you can have concrete which is, has a sort of sparkle to it and has a character according to where you've got the raw rock. And I think people forget that really concrete is made out of natural stone at heart. The interesting thing on this job was that the client was prepared to really get involved in the whole design and construction process. And we'd identified the key thing about concrete was making beautiful formwork. The concrete is just an imprint of the joinery that you make in the first place. So you have to have a beautiful bit of cabinet work, which is absolutely perfect. And once again, the building site is like the Battle of the Somme or something, but you've got to keep this perfect joinery. And David Mellor made all the formwork, which was oversized panels of plywood, and with very carefully made joints, which in fact had combinations of aluminium extrusions, which were specially made, and rubber extrusions that were gaskets that were specially made. And all those things created the very subtle features in the slab. It was basically a flat slab. The engineers on the project were Bureau Happel, and we worked with Michael Dixon. And we had a flat slab design, and it was the essence of it was that the columns and the slab were all monolithic, and we really wanted to see the fact that there was no difference between the walls and the columns and the slab. We were trying to exploit the monolithic nature of the material. And I think what we found, what was incredibly, again, a revelation, was the sort of precision from David's background in manufacturing precision objects, that when they're brought to the building site, we were able to achieve something far better than you could get out of the industry. But the problem was getting the industry to handle the materials properly, and because they're not normally used to anyone expecting the concrete to be a finished product. And we had endless problems with, how do you stop the grout loss from the columns, and how do you, handle the materials, because everything you do is reflected in the surface of the concrete, and we were anxious not to treat the surface of the concrete in any way. We just wanted to see it as a moulded material and feel the fact that the forms were leaving their imprint in the final building. And you can see here some of the details. For example, the special rubber collar that was manufactured for this job, and the considerable number of details that were worked out with David. And then you can see again, and these panels needed to be treated with enormous care. You can see here again, this is an aluminium extrusion that was jointing the panels and provided an indentation where we had joints in the concrete between pores. And this shows the retaining walls. It's somehow trying to keep a clear head when you're looking on site. What does all this mean on the finished product, and and how you can keep it. You've got to keep the forms absolutely clean and in perfect condition, in order that because anything that you do wrong is there for good. And it sort of took. And really, I think the sort of design tools that you need is not just designing it, but it's how to implement the design, because you will never get anything out of it unless you have the method and you can somehow communicate it to the workforce as to how you get what sort of finished result you want. And we had to think about everything, about how the reinforcement was. We didn't want any support off the formwork for the reinforcement cages, so we had these light fittings that cast in, and the reinforcement basically spanned between the light fittings. But it needed a lot of thinking. You had to think about the concrete from the inside out, and then was how you pour the concrete. And we found terrible problems with the type of vibrators that were used and we asked the Japanese how they did it, and they said they'd given up on all of that, and they just had hundreds of men shoulder to shoulder with bamboo rods compacting the concrete in the bottom of the forms. We could never persuade this contractor to do it, but it was. But we could see the reason. It's actually, for Fairface concrete, it's a hand finished job, and then the fit, literally hand finishing. One of the people we asked, and Tadao Ando was over here, and I asked him about how he got such fantastic quality on the concrete, and he said that he got all the year-out students in his office out onto the site with sandpaper, and they would sand down every square inch of the building. And we drew the line at that. We weren't going to do that. But in fact, David and his team, David looked very sceptical at first, and then he thought about it, and he thought, well, actually it probably is going to give a better finish. And he and his workforce got out there with the sandpaper and sanded every square inch of the slabs and the columns. And it gave a fantastic finish, because you get the perfect compaction, you get all the imprint of the mould perfectly revealed, and but you remove the latents from the concrete, and you reveal the qualities of the sand and the aggregates that are there. So if you've got the time, I recommend that. So then in a few shots of the finished building before I just talk about how we sort of went on to develop some of the skills that we developed on this building. And you can see it in the context. In fact, this building over here was developed by Conran Roach. It was designed by Conran Roach at the same time, and that's our building, which is somewhat dwarfed by these other buildings on the other side. But I think what we were quite anxious to do was to have something which is a tough architecture that went with the dockside architecture with a very robust frame, and it would provide a fairly neutral framework that would allow the activities to reveal themselves, but a beautifully crafted framework. And I think in many ways the Conran Roach building is almost the antithesis, in that had a frame inside and was clad with with panels on the outside, and reflected a lot of the more normal way of building things. But I think in a way you can sort of sense the lack of fat on the skeleton of our building, because we really stripped everything off. And then this is two views of the interior, and you can see the light fittings which were cast into the slab. And this is something that we had only just begun to wake up to, the fact that you can mould concrete to take all sorts of things. You can cast holes in it, and you can make it into quite a sophisticated honeycomb of different systems and services, all interleaved with the structure that's there. One of the things that we found as we went along, in all the problems that we had casting, these retaining walls, even though everything looked all right before we cast them, this one came out with an extraordinary sort of stratum-like pattern through it. You could see these sort of waves of concrete as they sort of poured slightly different coloured concrete one after the other, and the cold joints between them. And for this building, it looked absolutely terrible. And in fact, we had to. 6 columns were demolished, and this length of retaining wall were demolished before we could get the finish right. The ground floor took a long time to get off the ground. Here the men demolishing the retaining wall. But something from that stuck in our mind for a later project, because although it wasn't right for this project, this funny sort of strata of concrete running through like veins in the surface were, in another context, could be quite beautiful. And there was an idea that we took on to the Westminster Station, which is now being constructed. Now, this is it's under the Parliamentary Building, so this is the Parliamentary Building by Big Ben, and at the moment there's a big hole in the ground. And underneath there's this enormous underground box, which is going to be 30 metres deep by 30 metres wide by 70 metres long, where escalators connect the Jubilee Line station, Jubilee Line platforms with the District and Circle Line and the ground. And then above we have the Parliamentary Building structure, which is spanning across onto these 6 columns in the middle. But when we came to the techniques of how you construct this underground concrete box, something from that David Mellor retaining wall was demolished, stuck in our minds, that actually there's a sort of beauty, like at Petra here in Jordan, where you have these buildings that are carved out of a hillside, and you can see the sort of rock strata running through, that actually you could get some of that feeling of this sort of geology that you're just hacking out below ground. And when we were talking to the engineers on the Westminster Station job, we discovered that the way that you construct these enormous deep pits is with a diaphragm wall technique, where you excavate in the clay with a grab. This is all engineers' drawing. So and these are about 40 meters deep on the building, under bentonite, and you excavate this trench, and then you fill it up with concrete. And what you're using is the sort of clay that's left as the formwork, and then later on you excavate down between the panels of the wall, and then the walls of the station are revealed as the imprint of the subsoil of London, which has formed your formwork. So we thought that this this would be the solution. We just accept the fact that, that's what the walls are. And knowing that it was going to be very difficult to control the quality of the concrete, we had almost encouraged them to do these cold joints and these poor mixes of concrete, because you get something of this natural geological effect. And what was quite interesting was at the same time reading Micolucci, who designed this church, the Autostrada in near Florence, where he likewise sort of analysed all these old cities, these excavated and these sort of natural geological architecture, and he'd done a sort of fantastic blend of natural materials, some formed and some rough, and that was a fantastic inspiration. And this is the Jubilee Line station, where you have this formed grid of buttresses and wailing beams with these flying shores running across the middle of the box, and in these panels here you'll see the sort of imprint of rotten concrete, but purposely rotten and purposely rough, that's used the sort of clay that was excavated away as its former. Then going on from there, we went on to more sort of structural development of concrete, having really regardless of the material properties, what's the sort of structural expression that you can get. And Compton and Edridge stands at Lord's Cricket Ground. We started developing this aesthetic of you mould the slab to respond to the stresses in the slab, and then actually the reinforcement pops out of the slab where there's only tension, and use the concrete where it's good in compression, and it's pulls, and the steelwork is pulled out and becomes trusses, which are then embedded in the concrete underneath. And then the next project where we really took the idea to extremes of concrete as a moulded finish was on the Schlumberger building, second Schlumberger building at Cambridge. And this was really fairly faithfully following Nervi. This is the first floor slab. These slabs in these laboratories here are the first floor slabs of these buildings. It's a two-story building, very similar to the solid state logic building. And you can see there's the first floor slab, and all the services are up here. And it's taking the idea we used on David Mellor's building, where you have the light fittings and the conduits embedded in the slab. Here we would actually form much bigger recesses and express the structural forces in the slab, but also feed the air down from the floor above through holes in the slab, and also embed light fittings in the slab, and once again express it as the structural finish of the building. And the sort of lead for that, this is a Nervi building from the same book, but the idea is that you take these isostatic lines, which are the sort of points of equal stress in the slab, and you configure your ribs to follow the lines. This is a laboratory experiment that shows how the stress distribution is in a plate. And you take those lines of force, and then you design your structure so that all the ribs are equally under equal stress under a normal loading condition. And here Nervi had used ferrocement as a permanent formwork that would then form the former for an in situ topping. So we're taking this a step further from David's building. And again, quoting from Nervi, he is very poetic. He can make you really excited about reinforcing rods, because what he says is that you should understand the flow of stress from bar to bar and from reinforcement to concrete so as to channel this flow in the simplest and most natural ways. And the pattern of steel should always have an aesthetic quality and give the impression of being a nervous system capable of bringing life to the dead mass of concrete. And in many ways, I think this is the most sort of graphic example of how you form these ribs in the ferro-cement forms. And then you lay the reinforcement in a pattern. And the reinforcement pattern, in a way, is a thing of beauty in itself, which is then reflected in the slab underneath. And here you can see a lot of the lessons we learnt from David's building, where we cast in these support, the light fittings and the duct apertures, and thread it in with the reinforcement. This was the finished building, where you could really sort of literally read how the structure is working above your head. And then on to the next development, really the last main development, is how you use other properties of concrete. You know, having exposed it and used it as a visible structure, what about the thermal properties? And every time a building's published, predictably, someone writes into the architectural review saying they stood a cold bridge between the inside of the building and the outside, and you know, how on earth it's ethically wrong for architects to put cold bridges, and you know, that's something that's so energy wasteful in a building. And for us, it's always a paradox to get this very straightforward expression of a building where you expose the structure and strip things back. You know, how much of a penalty are you paying? And it's something that on other projects we've tried to develop the argument. You know, well, what is actually happening? Is it so bad? You know, do you need to solve the problem that's of a cold bridge? And this was in fact on the parliamentary building. We were looking at stone piers when we thought they were going to be exposed on the inside, and with plenty of engineering software, you can actually find out what the temperature contours are inside. So this is not like the isostatic lines, the structural lines. Here you've got another set of contours going through the same bits of concrete or stone. And what this proved was that it would never reach the dew point, and there would never be condensation. And in fact, the temperature is relatively stable, and that the heat loss is really nothing to worry about. And this is. And you really need to take an overall picture of the building and stand back and look at, you know, what the problems are that you're trying to solve. But we've sort of taken this forward in a more positive way on later buildings where you use concrete slab. And this is the new parliamentary building where this is a section through a model where there's a waveform slab, which is a corrugated slab that spans 13 meters, and it gets its structural properties as a thin plate, which is given this stiffness by the corrugated form. And here, this is a really active part of the environmental systems of the building. And what we have is the heat gathers in the top of the room and is absorbed by the slab, and the slab is cooled from above because air has passed over the top of the slab here. And then this is a CFD analysis by the engineers of how the heat transfers in and out of the concrete surface, and how it analysing it as a thermal mechanism. And this is something that actually forms a very important part, because you've got this fantastic area of radiator in the building, which, you know, doesn't need to be very different in temperature from the air inside. And on the parliamentary building, we've really sort of developed perhaps our most sophisticated use of the concrete slab as part of the architecture, because here you can see the slab is there. It's used as a heat absorber or a capacitor. It discharges the heat overnight. We're also using the underside with a sort of micaceous sand in the concrete as a light reflector. So we have light shells in the window that bounce the light off the slab, and it redirects light towards the back of the room. And so the concrete slab is also part of your lighting system. It's also linked into the air paths within the facade of the building, that then the air is fed in across the floors, and it forms part of your air ducts of the building as well. And it also provides your finish. It's the ceiling to the building. So in many ways, that's where that sort of experience that really started off with David Mellor's building on concrete, that's where it sort of led us on our most recent project. But this, going back to the analogy at the beginning, is like the sort of banquet where we've got these exotic materials of, you can see again the sort of plate, but this is aluminium bronze plate, and we've got a special mix of concrete, and we've got stone instead of concrete in the columns. But the sort of very immediacy of the David Mellor building at Shad Thames somehow gave us that intimate knowledge of how those materials work and how we can use it as part of our vocabulary with some confidence. And then finally, as a postscript, this is the building as it is today. It's Terence Conran bought the building from David Mellor and fitted out the apartment, and it's added on a few canopies and things. I think our only sadness is that the concrete that David laboured over, hand finishing, is painted with a coat of emulsion. I think that's otherwise I'm sure it's a good home. Anyway, that's all I've got to say. Thank you very much.
Some questions. So it's the project that really raised a lot of interesting issues in relation to construction. So I'm sure that there will be some questions from the audience. Who's going to ask the first question? Sorry, go ahead. Do we have the microphone? Can you just use the microphone, please? Sorry.
What was used for the building line to build the facade of the building over the pavement in front of the neighbouring buildings?
Well, in fact, that was the original building line, and we scooped back. We created a bit more pavement because really those buildings are completely sheer on the pavement there. There really is no pavement because they were just all warehouse buildings, and that building originally projected forward, and so we kept the building line as it was above, and then created a walkway underneath.
So subsequent buildings have actually retreated from the original.
No, in fact, it's all pretty much along the line of the original. What we did do was to open up a space between the two buildings, and there's the Conran Roach building and the Mellor building. They were, and the view was sort of opened up between the buildings. But there's a fairly haphazard building line there. There's just, whatever people found, they just built once upon a time and carried on building like that. They're chimneys, which they're chimneys, which there's the question about the Zeppelin mooring mast on the top of the building. In fact, they're part of the air handling system because we've got an air system where you take the air in at roof level and it goes through a heat exchanger. So you take the air in at the bottom of the chimneys and it goes in through a heat exchanger down through the building and then comes up through the building and is exhausted out through the top of the chimneys, having preheated the incoming air. So they're actually doing the opposite of chimneys, in old houses, which are about heating the building. These are more about ventilating and cooling the building.
One question that would be, I think, interesting if you could expand on this, is the way in which maybe the work in the office has changed in relation to this discussion or question of materials, because I think one of the things that seems very obvious is this: there seems to be very much a kind of rationality at work. Again, you were building on this sort of relationship of the project with the work of Khan, and specifically the issues of construction as something that really also then the simplicity. And I know that the project was designed initially very quickly. There's something about this act of the project being very, very simple, and yet, of course, there's a lot that has to do with the kind of specifics of attentions to details and materials. Is there a way in which you could maybe say something about the relationship of these kinds of attentions, these kinds of crafting of details in relation to the question of mass production, what is available on the market, and so on? Because I think that, again, just thinking back about the sustainability and the whole idea of the way in which the office is involved in research, how is this notion of working in detail for you has some kind of connection to a critique of mass-produced materials, or the way that it affects the way in which mass-produced materials might be modified? I'm very much interested in.
I mean, I think it's quite a dilemma, because in many ways the sort of ideals behind the buildings are the same as those of the modern movement, which is that you should be deploying industry to produce much better standards and much better crafted buildings on a mass scale. And then you find actually as time goes on, the industry sort of really abuses that, and actually there isn't a building industry there that can deliver the buildings that you set out to do. So, in a way, a lot of our buildings are sort of one-man crusades, campaigns to reform the building industry, and I was quite interested. I think we had with David Mellor a client who's quite interested also in sort of reinventing construction techniques, and it's quite depressing because you do your little bit, and we build up our vocabulary, and we then use them again and again. But there isn't really a sort of a building industry that is there to respond to it. And almost any building. I mean, to do, you sort of realise that the buildings that Khan did, and almost every sort of great building is fantastically hard fought over. You need a sort of craft to deliver what your ideals are for the building, and you can't just design something and expect someone to do it. But part of the design exercise is inventing the way you procure it. Do you have the right form of contract? Are your engineers able to sort of give you the right answers? And everything has to be just to do the simplest thing. You've got to sort of almost reinvent it yourself.
But is there a way in which this material is documented? I mean, apart from, it was wonderful that you're able to present this material in the lecture, but at some point maybe universities used to do this kind of research, or maybe the industry was doing. Now, is there a way in which the relationship between the kind of research that gets done in the office can actually be documented differently?
Yeah, I mean, in the end, I think the sort of cutting edge of a lot of the sort of building buildings is in practices, and you're just so busy getting onto the next building, you never sort of, you never stop to document it. And I think it's depressing at how hopeless universities are in, there's no research that you see at first sight that's of any use to what you're doing to push the state of the art forward. Maybe there was once upon a time when people were developing reinforced concrete architecture. There's a lot of scientific research, and that was fed into the industry and it fed into the profession fairly quickly. But in many ways, you feel that a lot of the universities are trailing behind, and that in a sort of disorganized, stumbling way, and doing the bits of research ad hoc, you're probably at the cutting edge of what's going on.
It must have an enormous effect on the price of such a building. I mean, how does one face a project which is for an ordinary client?
Well, David was an ordinary client, and but in many ways that one was about using people for what they're good at. I mean, actually, in the end, we used an ordinary concrete contractor, but the sort of expertise we had to put in was the client making the formwork and doing that. But the materials were cheap materials. There's nothing really inherently expensive in there.
So the cost of that building, overall cost of that building, accepting that Mellor put in a lot of time and you guys put some extra time in, the actual cost of that building and the contract was rather normal?
Oh yes, I would have said it was a very economical building, and part of the thing where you've sort of eliminated whole areas of construction, like the suspended ceilings and curtain walls, and everything was. We were trying to get one element to do as many jobs as we could get it to do. So I think it was probably an extremely economical building compared to probably compared to all the surrounding buildings around there.
Thank you very, very much. Thank you.
Thanks.